Hey guys, so in the last video, which was quite some time ago, I've been terribly busy. A lot of things have happened, so I'm a little bit behind on some of my projects. But I wanted to catch up on these while I had an opportunity. But I noticed when I started generating my toolpaths today to carve the template for this Jackson X Series V repair, I noticed that I had an error where I forgot to show you guys how to correct the DXF file curves that we imported. So I thought, before we run out to the machine, that I would like to show that. I think I have done it in a different video, but I forgot to do it in part 2. So I'm going to cover that really quickly. So this is very similar to what you guys had if you followed along. And I'm going to take these vectors that we imported and I'm going to go to node edit mode. Now if you look, you see all this garbage. This should be a straight line, and you see all these points in it, and all these points in this line, and all of these points where you have tons and tons and tons of little lines and arcs and such. Well, we need to get rid of that. And how we rectify that is we highlight the vector, and then we go over to this tool here, which is the curve fit tool, and we click on that. And we're going to select Bezier curves, and we'll leave the tolerance at 0.01 millimeters. Some things you don't really have to be even this accurate, but I like to leave it that accurate. And I also like to select the replace selected vectors. So we click this preview button, and this is what the software will convert the imported DXF curves. This is what it would convert it to, and I'm going to hit OK. All right, so now if I click on that again and I go to node edit mode, now we have something really nice to work with. So another thing that I want to do, since you guys may not want to do this, and you probably don't need to unless you're doing like me and you're repairing a guitar. If you are doing this because you traced a unit and followed along and you're just wanting to build your own guitar, you can go ahead and just generate your toolpaths based on the video that you followed along in part 2. Just go back and do this. That's the only change that you have to make. And you wouldn't have to do the engraving. I'm going to do engraving for a different reason. So I'm repairing a Jackson X Series V, model number CDX22, that has a broken upper wing. And for me to do a good job on this, I need for my template to fit the body pretty good. It doesn't have to be exact, but and it can be a little proud. The template can be a little proud of the body, but the body cannot be proud to the template. And so what I'm going to do is I'm going to generate a toolpath. I'm still going to use the profile toolpath, and I'm going to select a V-bit, 15-degree V-bit, and let's speed this up. Should have done that before. And I'm going to select that tool, and I'm going to change my cut depth to 1 millimeter. That should be enough. And maybe I'm going to go to my passes, edit passes. I'm going to delete one of those passes and just go 1 millimeter. And I'm going to go 1 millimeter in one pass. It should be fine. Now, unlike your toolpath where you'll be carving on the outside, so that we keep this template we want this to be on the line. And we'll call this engrave. And we hit calculate. And now we can preview. And there we have where we can see we're tracing the body. Now the purpose in this is I want to put this, basically etch a line on this thin sheet of MDF, and then I'm going to set the damaged guitar on it and take measurements and see how close I am. And depending on how close I am, I'm either going to go ahead and carve my template, or I'm going to edit these curves. But for now, what I'm going to do is I'm going to generate this engraved toolpath, or generate G-code from that toolpath. I'm going to hit save, and we're going to save the selected toolpath. And we're going to call it engrave, and I'll just call it take two, but you can call it whatever you want. And then now we'll have G-code. We'll go ahead and do our carve. I want to center this piece based upon my center line for my workpiece that I marked earlier. And I'm just going to run this down. And it doesn't have to be exact. I'm going to tap this over a little. And it's pretty close. So I'm going to tighten these clamps up. I'm not going to put them terribly tight, because now I got to do the same thing at the far end of the table. We'll go down here to the far end. See, it's going to be off a little bit down there too. But like I said, where it is now, it's probably plenty close enough. Okay. So then now, all we have to do is come down here to the center. Slow it down a little bit. And that'll be close enough. And that'll be the Y0. I'll take this piece of paper that's 1 millimeter thick, and I'll bump the Z down until it just touches. And that's good enough because we're going to millimeter. Okay. Z0, and then now I will raise the Z up just a little bit, and we will do the engrave. We turn on the spindle. And we'll go for it. so now the next thing to do is to lay the unit on top of the template proof, if you will. Okay, so I went in and I measured, or I did lay the unit down on top of the template trowel, and over on this side, at the end of where the break is, I was in around 1 millimeter, and it faded into the body correctly up here and was almost directly on the line everywhere, which is very good considering I had 2 or 3 images of slightly skewed instruments to go by. But what I decided to do is in VCarve, and I wish that I had taken the time to record it, but in VCarve I measured from the tip to where it was off the 2 millimeters or the break on the instrument, and it was 430 millimeters roughly along this perimeter edge here. And what I did was I wrote down the X and Y coordinates when I measured along that along this vector, 430 millimeters, and then I dropped a circle with a 1 millimeter radius at that point, and then I came inside here and inserted a point onto my vector, and then I drug that point out to the outside of that circle, which what that did was that pulled that segment out 1 millimeter, which means now there's a slight contour, and then now this comes out a little bit. It's about 1 millimeter, and it should be almost directly even with the body. If it's a little proud, that's not a problem. I can sand that, but it can't be inside. The body can't be proud to the template. Okay, so after we engraved the MDF to proof the toolpaths, I did notice a couple of little problems. Overall, the toolpath looks good, but there are some things that need to be fixed. And one of the things that I noticed was on this side, where the wing is actually broken, 430 millimeters from this point along this vector, we're inside roughly 1 millimeter. And so what we're going to do now to fix that is I'm going to take this measurement, I'm going to go up here and I'm going to trace down this line. I'm going to stay on this vector until I get to 430. It doesn't have to be exact, but close. The closer the better. Yeah, let's do that 430.41. Okay, so I have my X and Y distances, and I wrote those down. And now what we're going to do is we're going to turn that tool off. We're going to draw a circle, and we're going to place that circle, a 1 millimeter radius circle, with the center at those with the X and Y position that I located with the measuring tool. And this is what we end up with. Okay, so now that we've done that, we go back to this vector, and we are going to go to node editing mode, and then we're going to go in here and we're going to insert a point, all right, insert a point, and now we're going to take that point and we're going to drag that point until we hit the outside perimeter of that circle we just drew. All right, so now what that's going to do is that's going to pull this side out so that now this point won't be affected. So all of this should still be aligned. which was aligned with the unit. Now we should be pretty close. And the other thing that I noticed, and we can go ahead and delete that now, is that the entire thing needs to be offset about 1/2 millimeter. So we're going to go here to this offset tool, and we're going to say outward, and we're going to say 1/2 millimeter. All right, so now we have this new vector. Okay, that new vector is going to be our new tracing point, but we're not going to trace. It was extremely close enough that I know this is going to be good. So now we're going to take that new vector that we just created. We're going to close this. We're going to go back to the profile toolpath, and we're going to go 18.9 millimeters deep because it's a 19 millimeter piece. We're going to select a tool, and we're going to use the 1/4 inch 2-flute tool, and we'll select that. We have 6 passes. We're going to go to the outside because this is the segment that we want to keep. We're going to add some tabs. We hit edit tabs. I'm going to tell it to avoid the corners, and I'm going to tell it to add 2 tabs, and then I'm manually going to go up and I'm going to pop 2 tabs in here. And I explained earlier what that was for. Then we're going to close. So now we have we're going to have the new tool path, which is 1 millimeter larger over the entire instrument. Will be 1.5 millimeters in this segment here, which means that we should be corrected now. Now we're going to add a ramp, smooth ramp, for a distance of 25 millimeters, and we're going to call this CDX 22, or well, first let's just call this parameter. Calculate. Now we can preview the path, and there we have it. And this should be very close to the actual instrument. So now what we're going to do is we're going to select the perimeter, and we're going to go save toolpath, and we're going to save that toolpath, and we're going to call this toolpath CDX 22 corrected parameter, and save. Okay, so now we're going to go back to the machine, and we're going to carve this on the 6 millimeter. Oh, this is 6 millimeters, not 19. So we're going to say 6 millimeters. Calculate. And now save it. That would have been bad. I'm tired. It's been a long night. Corrected parameters. Yes. Okay. Now we're going to go back to the machine, and we're going to carve this. Now all I did was change the mill out, and I did decide to go with this. I decided to go with this other mill, the 2-flute. And now I'm just going to lower this down till it touches. Alright, so now that I feel that, and this is 0.1 millimeter, this is 0.1 millimeter thick. So now that I've done that, I can step over to my controller and put it on 1.1 millimeter and bump the Z, and it'll go down 0.1 millimeter, and that will be my new Z0. Okay, so that's all I've done, and now I'm going to raise this up, And this is going to probably get a little bit messy, so I'm probably going to have to give you guys a little noise. And then the next thing is I load in the program, and then I turn on the drive, and I think this is supposed to be 230. So that is the trial template. Okay, so everything looks good now. So the only thing that has to change is the thickness. So we're going to go to perimeter, and we're just going to modify what we had. And I'm going to go 18.8 to leave a little bit at the base of the part, so I don't like hitting my waste board if I don't have to. Everything else remains the same, and then we preview it, and then we hit close, and then now we select that perimeter path, save toolpath, and there we go. We're just going to use that same. In fact, we'll call it 19 millimeter perimeter, and that's what we're going to run now. So we'll be back at the machine carving the last piece, and then we will be done. And now we are ready to carve the actual template. And there it is, minus cleanup. And that is the template that I'll use for repairing the CDX22 X Series Jackson B.